In this video, we are going to prove that the ratios of areas of similar triangles is equal to the scaling factor squared, which is denoted as k, right? Scaling factor is denoted as k and it squared, so k squared, this one. All right, so it's given that these two triangles are similar. Triangle ABC is similar to triangle DEF. You can name it as PQR or whatever. These two triangles are similar, so we named it such a way, like ABC and DEF, and it's given that these are similar. But okay, so AB is corresponding to D, like that I made it similar. All right, so it's given like that, so let's prove it. And before that, let's give a name to this perpendicular here, which is perpendicular. Okay, this is perpendicular because we are dealing with base times height, right? And half times half, so we need a altitude which is perpendicular to the base. So let's name this as M. Oh wait, I will write it P because that feels cool. And M, let's write this as M. Okay, cool. So let's just prove that one. All right, let's go down. Okay, so we know that area of triangle ABC, let's write that out. The area of ABC is equal to half times the base is BC, times the altitude, which we have denoted as AP. Now let's divide that by area of triangle DEF. All right, so it is okay, so it is half times EF base times height, which is DM. Now quickly we can cut the half, and we can see that it is BC by EF times AP by DM. Okay, so we found what will be the ratio, right? The ratio will be like this, BC times AP by EF times DM. Okay, that's the ratio, but we need to prove that it is the scaling factor squared. So we have a scaling factor in this equation itself. It is BC by EF. We know that because they are similar, right? BC and EF are corresponding sides, right? BC and EF, we wrote it like that, so they are corresponding. So this divided by this, we will see it's a scaling factor of this triangle. We can find the scaling factor. Okay, now this thing to be proven is that we need to see that if AP by DM is also the scaling factor. So yeah, let's prove that if AP and DM is the scaling factor, then we will get K here and K here, K here and K here, so K squared. So we have a K here, but can we get a K here, which means will it be equal to BC by EF? Let's go ahead and find that. We know that angle B here is corresponding with angle E here, and there's 90 degree here and there's 90 degree here. So this triangle ABD and this triangle DEM are similar. So we can write that triangle ABD, or it's not ABD, sorry, it's AP. Okay, it's AP. Okay, so ABP is similar to triangle DEM by AA similarity. Okay, cool. So with that, we can find out this thing AP by DM. So let's write AP by DM. We have them corresponding. AP by DM is equal to, we can find out it is similar to AB divided by DE. So let's just write that AB divided by DE, and we got this relationship. Now we know that triangle ABC is similar to triangle DEF. We know that AP by DE is here. So, and also we can find that BC by EF. So we can say that from this equation 1 thing, let's just write that down. From this thing 1, we find that BC by EF is equal to AB by D, same scaling factor, right? AB by D. So from that itself we can find that AP by DM is equal to BC by EF. So if this is equation 2 per se, and this is equation 3, and that means 2 is equal to 3, just equate them and we'll find that AP by DM is equal to BC by EF, because whatever is the value here is the value here, so making them having this relationship will help us prove this. So from this equation we have found that BC by EF into AP by DM, so AP by DM is basically BC by EF, so we can write like this, right? And BC by EF times BC by EF. Okay, and we will get BC by EF squared. So BC by EF is basically our scaling factor, and if you do the similar thing to the corresponding sides of AB and D, AB by D will get the same whatever BC by EF is. So similarly, whatever we do, we will get the scaling factor, whatever the scaling factor is constant, right? So we can generally write as it is equal to whatever the scaling factor squared. So hence proved. All right, thanks for watching. Have a nice day. Bye.